I am Lakshmi Lata from second year ECEC section. My roll number is 24BQ18043. My seminar topic is registers. Registers are defined as a register is a circuit consisting of flip-flops which can store more than 1 bit data. The register is nothing but a sequential logic circuit in digital electronics. Before going to know about, you must know about the flip-flop. First, read about the basics of flip-flop. In digital electronics, logic gates, flip-flops, and registers are very important and interesting topics because they are basic components of microprocessors, CPU memory, etc. Examples of register: the accumulator, stack pointer, and program counters are the examples of microprocessor are nothing but a register. Types of registers: buffer register, controlled register, shift register. In shift registers, there are two types: shift right register, shift left register, bidirectional shift register, SISO register, SIPO register, PISO register, PIPO register, universal shift register. The first type of registers are buffer registers. A buffer register in a digital electronics is a storage unit that holds binary bit built using series of D flip-flops, with each flip-flop storing 1 bit. Data is loaded into the buffer registers at each clock tick, with outputs matching input bits at each leading clock edge. Its primary function is to act as a temporary storage area for data being transferred between devices or components, helping to match the different speeds of faster and lower devices. This is the representation of buffer registers using D flip-flops, and the clock pulse is commonly given to every flip-flop. Another type of registers is controlled buffer registers. Controlled buffer registers are used to replace the buffer registers as buffer registers lack control over inputs, causing uncontrolled outputs. This is the disadvantage. So, to fix this, controlled buffer registers are used. In this design, tri-state switches are used to control the operation of loading and retrieval of the data from the buffer registers. Here one has to pull the LD or WD control line in order to store the data, and while another control line to made to read the data. This is a logic diagram representation of controlled buffer register. It is built using D flip-flops, and another type of register is shift right register. The register that transforms or shifts input data rightwards is called the shift right register. When the rising and falling clock edges arrives, then the stored bits shift right according to the 1 bit position per clock pulse. Data is entered Data is entered into the register from the left side, and data is retrieved from the right side. This is the logic diagram representation of shift register, and clock pulse is commonly given to every flip-flop. Here, D is the left side part of the register. Here data is entered, and through this it is transferred to another flip-flops. Finally, we get D out, where the data is retrieved. Shift left register. The register that transfers or shifts input data leftwards is called shift left register. When the rising or falling clock edge arrives, then the stored bit shift leftward according to the 1 bit position per clock pulse. Data is entered into the register from right side, and data is retrieved from the left side. Bidirectional shift register. This type of register allows shifting of the data either to the left or to the right. It can be implemented by using logic gate circuitry that enables the transfer of data from one stage to the next stage, to the right or to the left, depending on the level of control line. The right or left is the control input signal, which allows data shifting either towards right or towards left. The right or left is the control input signal is low. The data in the registers shifts towards left. The right or left is the control input signal is high. The data in the shift register shifts towards right. This is the logic diagram representation of bidirectional shift register. In this register, we can easily perform both right shifting and left shifting using this logic diagram. Here, these AND gates and NOR gates both commonly can be replaced by 2 by 1 multiplexers. SI-S4 register. In serial out, SI-S4 register accepts data 1 bit at a time through a single input line and outputs data serially. Data enters and leaves 1 bit at a time in a serial sequence, typically made of multiple D flip-flops connected in series and synchronized by a common clock. Here is the logic representation of SISO register using D flip-flops, and the clock pulse is commonly given to the each flip-flop. This, as we give the input to the D, it is serially given to the all flip-flops, and then finally we get serial output. Similarly, as there is another register, SIPO register, a serial in parallel out shift register accepts data 1 bit at a time through a single input line and outputs data parallelly through multiple lines. Data is input 1 bit at a time and outputs all stored bits in parallel. This is the logic diagram representation of SIPO register using D flip-flops. Clock pulse is given commonly to every flip-flop and clear is also given to the each flip-flop. As the input is given serially, the output is obtained in every flip-flop as parallel. PISO register. A parallel in serial out shift register accepts data multiple bits at a time through multiple input lines and output bits serially through a single line. PIPO register. A parallel in parallel out shift register accepts data multiple bits at a time through multiple input lines and outputs data in parallelly through multiple lines. Another type of registers is universal shift register. A universal shift register is an n-bit register that supports both left and right shifting as well as parallel loading using n flip-flops and n multiplexes with a shared select lines to control the data flow. It combines the features of bidirectional and unidirectional shift registers, enabling versatile data manipulation, shift left, shift right, parallel load, fold. This is how the operations are worked. If S0, S1 are inputs, and here are the operations based on the values of S0 and S1. If both are 0, 0, hold. If one is 0 and one is 1, shift right. 1, 0, shift left. Both are 1, parallel loop. This is the logic diagram representation of universal shift register. Here we used 4x1 mugs and D flip-flops. Thank you.